Hello. Let us consider the effect of the position taken by the center of gravity on the stability of a rigid body. To do so, let us define stability. Stability is the ability of a mechanical system to keep the initial position under minor action or the ability to return to the initial position also under minor actions. The positioning of a center of gravity is a serious competitive advantage, especially for automotive industry manufacturers around the globe, and specifically, it is the lowest center of gravity that is an immediate factor influencing stability of a vehicle. As of today, the leader among the automotive manufacturers in terms of the lowest center of gravity is Subaru Automaker Division, primarily due to their development of a horizontally opposed engine design. You are invited to read Subaru's marketing message on the screen, which states proudly and explicitly that they have done their best in order to have the lowest possible center of gravity for a specific model of their car. Although their ordinary cars have the center of gravity lower as compared to their comparable models by other manufacturers, this low center of gravity is achieved by the corresponding seating positions and by choosing specific materials. We consider the effect of the center of gravity on the stability of a rigid body by the example of a compound uniform body, comprising a sphere and a cone which we can see on the screen. Let us make a statement of the problem. The task is to find the ultimate height of the cone of the compound uniform body abutting against a smooth horizontal surface, at which height the vertical position of the body is no longer stable. To solve this problem, we have to find the center of gravity of this compound body. Let us utilize the fragmentation method. Because the figure is symmetrical with respect to the axis z, the center of gravity is lying in the axis z. Therefore, the coordinates of the center of gravity along the axis x and y are equal to 0. To find this c, as we can see from the equation given in the picture, we have to find the coordinates of the center of gravity for each figure and the volumes of the figures. The cone volume V1 is equal to 1/3 pi multiplied by r squared h, which is a known formula to be found in the reference tables. The coordinates of the cone center of the gravity is the height divided by 4. The volume of the hemisphere is 2/3 pi multiplied by r cubed, and the coordinates of the center of gravity of the hemisphere is -3r divided by 8, a negative value because the reference point is in the point O, and the center of gravity of the hemisphere is lower than the reference point. Then substituting into the equation the following expressions for the volume and for the center of gravity's coordinates, we shall have the coordinates of the center of gravity of the entire figure as a function of height and radius. To determine the influence of the center of gravity on stability, let us consider various positions of the center of gravity with respect to the reference point. Let us analyze a few various positions of the center of gravity. To begin with, let us set the center of gravity above their region. Two forces are acting on a body, the gravity force and the normal reaction, which, when deviating from the vertical, are tending to turn the body clockwise. Thus, this position of the center of gravity results in an unstable condition of the body. In the case when the center of gravity is in their region, then the two forces acting on the body are balanced. At any deviation from the vertical, the body is at rest. The condition of the body with such position of the center of gravity is referred to as neutral. In the case that the center of gravity is positioned lower than their region, then the two forces acting on the body are tending to turn the body counterclockwise and return it to the vertical position. It is this position of the center of gravity below the origin that results in the stable condition of the body. Therefore, we can write down the condition for stability. The coordinate of the center of gravity is less or equal to 0. To find the ultimate height h, we have to solve the equation. Equating zc to 0 because the ultimate position is in the origin. The condition of the coordinate of the center of gravity found earlier as a function of height and radius is to be equated to 0 and to be solved with respect to the height. The ultimate height value is going to be the square root of 3 multiplied by r. A tilting doll is a perfect demonstration of the stability effect. Thank you.